So 1.1 today, our goal is to evaluate a function at a given value, including from a graph of a function, determine if an equation or a graph is a function, and evaluate a function at an expression. And we're going to start talking about domain and range. Okay, we have used these words already this year, and so I'm just going to go through this real fast. And I don't even care if you take notes on this or not. Natural numbers is how Mama taught you to count. 1, 2, 3, 4. Whole numbers, we add in 0. That's it. Integers, we add the negative natural numbers, okay? Still no decimals and fractions. Rational includes everything that could be written as a fraction. So if it ends, this would be 11 and 23 hundredths. This is a repeating decimal, so that started as a fraction. Irrational things, that 2.7e one they have there is e. They have pi, square root of 2. We talked about irrationals are those ones with. And all of these fall within real numbers. And then there's a little separate category we talked about the other day with the imaginary numbers, right? Complex when you add a real and an imaginary. It just happens to be on these notes, even though we've already talked about it. Okay. The best way to describe a subset of real numbers is interval notation. You need this to be comfortable with this. For the rest of your upper math career, you have to use interval notation for all kinds of things. Use brackets to say an endpoint is included. So that would be these guys, okay? And you use parentheses to indicate it is up to, but not including that point. We're going to use positive and negative infinity to include that it goes down forever or up forever or less forever or greater forever. So if we had x is greater than 18, is everyone good with those symbols? Sometimes students get really confused. The one that looks like a less here, this is like an L. This is a less than, this one's greater, okay? Don't use the alligator philosophy. That's just going to mess you up. So this says x is greater than 18. So it means 18 and up towards infinity, okay? The parentheses is on the left because of the greater than symbol, and an infinity always gets a parenthesis, never a bracket. Intervals are always stated from least to greatest, okay? So when we move, oh, this is, it says it's in the book, but you don't have the book. Is there, if you need more help with interval notation, I'll find a way to get it to you if somebody really needed a picture of this, or it'll be posted in Google Classroom, okay? Number 1, how do we say less than or equal to -2? I always picture it as a number line. If you had -2, it's going this way. It's an or equal to, so we need a solid bracket here, or an inclusive. It includes that. But when we write it left to right, or least to greatest, how are we going to state this? Bella, are you doing your notes? We would say negative infinity up to -2, and we get a parenthesis on the negative infinity and a bracket on the -2 because of the or equal to. How many of you are totally uncomfortable with this, haven't done it before? Anybody? All right, so we'll go kind of quick here. This one is greater than -8.8, so you'd have a -8.8. Because it doesn't have the equal to, it would be a parenthesis going up. And because it's going up, you're going towards positive infinity. So the answer we're looking for here is -8.8 to infinity. Okay. Can anybody else not write eights and infinities at the same time because they just feel like they're tipping over or something? All right. This says between 5 and 15. If you were doing a number line, it would be parentheses because there's no equal to and it's in between. So when we write it as an interval, it simply looks like an ordered pair, and you would have to know the circumstance to be able to tell that it wasn't an ordered pair. Like if it said domain and I saw this, I would know that didn't mean an ordered pair. All right, this is the one that messes students up. If you have below -11, okay, Or it could also work if we are above +1. So you would have a square bracket because it says or equal to, and you're going this way. There are two interval notations needed. It would be -infinity to -11, because -infinity is down here. And then up here, you would say, and from 1 up towards +infinity. Everybody okay with that? And what you're supposed to put in between, and I'm not going to worry too much about it, is this symbol that means union, okay? The union of this set and this set. All of the answers could be in either one of those areas. How are we feeling? This coming back? Oops, did someone need more time? You didn't have to draw number lines. I just do that to try to help so that it makes sense. All right. It says a relation is a rule that relates or pairs the elements of set A with the elements of set B. Set A is the inputs or the domain, okay? So generally domain represents the X value. And the set B contains the outputs or the range. So the range represents the Y value. A function, okay, if it's a function from set A to set B is a relation that assigns each element in A to exactly one element in B. All right, when you're talking a function graphed, it means it has to pass the vertical line test. If you're talking a list, it means the X's can't repeat and be paired with more than one Y. Okay, the X's can't be repeated and paired with more than one Y. The X is the independent variable and the Y is the dependent variable. The outcome depends on the input. So we say this is the outcome or the output. All right. A function, again, is a relationship that assigns each element in A to exactly one element in B. So 2 to 8 and 3 to 8 are okay. This works because none of these were assigned to more than one. It would pass the test. Do you guys know the vertical line test? I found a video, but it's like 2 minutes long. The vertical line test says if I can draw any vertical line anywhere and it ever crosses more than one point, then it fails the vertical line test and it's not a function, okay? So this is not a function, right? This is a function. This is not a function because a vertical line would hit it twice. Do you want me to play the video? Everybody's okay? All right, so this has repeated Y values, but the X's don't ever repeat. None of those are the same. So this is a function. If I were to graph this, I would go left 8, left 5, stay at 0, right 3, right 6. None of those repeat. Okay, doesn't matter that the Y's repeat. That has to do with the horizontal line test, which we'll learn about in a week maybe. This is not a function because it fails the vertical line test with that red line. Everybody okay? Y squared equals something. What do you think? If it has a Y squared, it means I can put in the same X and get out two different Y's. So it fails. It's not a function. How could I describe that? If I put in a -2 for X, I could put a 1 in here. 1 plus 4 is 5, but I could also put a -1 in here. -1 plus 4 is 5. So putting in a -2 could be a -1 or a +1 for the Y value. basically anytime y is squared or in an absolute value, it's not going to be a function, and I, on the quiz, will either give you something you can graph on your calculator, or a list of ordered pairs, or an actual graph already drawn, okay? I'm not going to give you an equation like this and make you try to figure out whether it's a function. By the way, bottom line is, if it's hard to graph on your calculator because it's got y in some weird form, it's likely not a function. Okay, to tell if a relation is a function, the vertical line test can be used on the graph. We talked about that. Okay, so let's put a couple examples. Draw a graph of a function. What do you want to draw for that? Any line except a vertical line, okay, is a function. Any parabola, opening up or down, is a function. Those would work for A. B, a graph that is not a function. If you wanted to do a line, you'd have to draw a vertical line. That fails the vertical line test because I could put a line on top of it. Mostly for a not a function, I would draw a circle or a sideways parabola. An absolute value graph is a function. Polynomial is a function, even if it looks like it's going straight up and down. This is also a function, even though it looks like it starts to go straight up and down. Those are called rational functions. Okay, all of those are functions. Questions? Everybody okay? Oh, here I go. Always clicking on something I don't want. Please go away. Okay. This is evaluating a function. You have to be able to do this for the quiz, but I hope this feels like a very Algebra 1 moment, except that there's lots of stuff to type here. This just means put in a -4 for the x in all of these places. So to evaluate this, you would type 4 times -4 cubed plus 6 times -4 squared plus 3 times -4. Is everybody comfortable that with why we're doing that? It said to put in a -4 into f of x. Someone can type that. I don't think it's going to be any fun for me to try to do it on here because I can't see. This is -64 times 4 again would be, yes. Did anybody else get -172? Okay. Do you need me to try type it, guys? Show you how to type it, or are you okay? Yeah. You would put, Elo, could you read it to me? 4 times -4 to the third, right? And then what? This is, Antoine, this is where you have to arrow to the right if you have a newer calculator. Go ahead. Squared. That was it? So I just replaced all the x's with a -4, and it's just as easy to just always use parentheses when you're doing that. Did it come out okay? All right. Now this one has a variable. So this is evaluating a function at an expression. It means you're going to replace all the x's with 2a's, and you're going to have to simplify. So it's going to be 4 times 2a cubed plus 6 times 2a squared plus 3 times 2a. Okay, can you take a minute and try to figure that out on your own? How would that simplify? I'm going to get an a cubed here, but be careful. There's a 2 times 2 times 2 and a 4 all multiplied together. Is it 32, guys? 2 to the third would be 8, right? Times that 4 out front would be 32. Did I lose anybody? All right, then this one is a 6 times a 2a times another 2a, or 2 squared is 4 times 6 is 24. And that's an a squared. And then on the back, 6 times 2, or 3 times 2a is just 6a. And I can't combine different powers of a. Yes, no, maybe? Antoine, did I lose you? You don't have to write it out, but you have to remember you're cubing the 2. So you could do 2 to the third on your calculator and then times the 4 out front, okay? And here you'd have a 2 squared times 6. I just wrote it out to try to maybe help it make sense to you. You're not adding, so it's okay to combine things. Adding like terms is a whole nother, unlike terms you can't do, but you can multiply anything. All right, evaluating a piecewise, this is a new concept. I don't think I put it on the quiz yet, but evaluating a piecewise, you have to read these rules, okay? If x is less than or equal to 4, I use this rule. If x is between 4 and 10, but not including them, I use this rule. If x is greater than or equal to 10, I use this rule. So put in a 1. 1 is less than 4, so I'm using the first rule. Everybody okay there? So I would have square root of 1 plus 1. Guys, what's the square root of 1? It's just 1. It's not plus or minus 1, it's just 1. So 1 plus 1 would become 2. Then it says put in a 3. Now 3 is still less than 4, right? So I'm putting in square root of 3 plus 1, which does not simplify. So you could get an approximation by a decimal, but I'm just going to write down square root of 3 plus 1. All right, when I go to put in a 6, I have a new rule to follow because 6 falls between 4 and 10. So I have to do 3 times 6 is 18. And if I put in a 10, 10 does not fall between 4 and 10 because this didn't have an or equal to. 10 is actually included here. This says from 10 and up. So I put the 10 in this rule. So I'm going to do 2 times 10 squared minus 15. If you type that on your calculator, I'm thinking 185. Did anybody double check me? Thank you. Again, I didn't put a piecewise on this quiz yet. You will eventually have to evaluate piecewise, but we get to spend a couple days later on piecewise functions. All right, find each function value. Same thing we were just doing. Put a -1 in. What's everybody going to do wrong there, guys? Anybody know what might go wrong? Yeah, we have to, whoops. When you put a negative in and square it, it's got to become a +1, right? So if you put it in your calculator, don't forget your parentheses. Then a -8 times -1 is positive, and there's another +1. You could have typed it just like this in your calculator, and it should come out 10. Okay, this is on the quiz. You need to be able to do this and simplify. Now, I don't really like that it uses x again. I think I used a different variable on the quiz. But we're going to put x plus 8 in where there used to be an x. Do you want me to change the variable? Will that make it more comfortable for some of you? Let's call this a plus 8, okay? So we're putting an a plus 8 in here and here. And we have to simplify. So it's going to say a plus 8 squared minus 8. But instead of x, we're putting in a plus 8 plus 1. Okay, on the quiz, I use a different variable than the function used, so I just changed it to an a. You won't have to change anything, it'll be different. But you have to simplify this. You cannot make this a squared plus 64. There's no shortcut. You have to do a plus 8 times a plus 8 unless you have the pattern memorized. And then back here, you're going to have to distribute. We'll get a negative 8a and a negative 64. And then there's a plus 1 on the back. Okay, when you FOIL this together, a times a is a squared. A times the outside 8 is 8a. 8 times the inside a here is another 8a. And 8 times 8 at the back is a plus 64. Now this one's kind of curious because when we copy the rest of that down, a bunch of stuff will cancel. This goes away, and I have a squared plus 8a plus 1. Does everybody understand that you have to FOIL that out? I just suggest that you just write it out that way. When you see that you're supposed to square it, just write it out, a plus 8, a plus 8. That's what I do, so that I don't ever do something silly like try to distribute. There's no such thing as distributing an exponent through a plus or minus in there. If it's multiplied, it's a different story. It applies to everything in there. All right, do we need to do another one of these? Which rule am I putting a 3 into? Be careful. Yeah, because this one includes the 3. See that little line there? It includes the 3. So f of 3, you would do 2 times 3 plus 10, which is 16. For 8.5, which rule am I going to use? Yes, it's greater than or equal to 8, so I use this. And what is this rule? Yep, the answer is just 42. So if you tell me to put in a 10, a 57, anything, it says just stay at 42, everything above that. It's kind of like if you were doing a real life problem where once you hit a certain amount, you pay the same for the shipping no matter what's in there. Kind of that kind of a situation. That's a piecewise function. Usually shipping cost is a piecewise function. All right, now we're going to talk about domain and range. I cannot highlight enough this sentence right here. It says domain, you read left to right, and it's X values. And range, you read bottom to top, and it's Y values. I hope this sounds familiar after we do a few, okay? So domain is X values, so you're reading along the X-axis from the far left going towards the right. This function starts at what X value? -4, but it's an open circle, so we use a parenthesis. Does that sound familiar? Means we're not including the -4. Then going to the right, this graph continues to head off to the right, yes? So we go towards infinity forever to the right. There will be points on this graph because of the arrow here. We're actually looking at this purple guy right here, okay? But he's going further and further to the right, so we say -4 to infinity. All right, when we go to do the range, we're talking about the bottom to the top. What is the lowest Y value? Again, your Y values are here. What is the lowest Y value that we have? -1. Again, it was an open circle, so we have a parenthesis. And the purple goes up, 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 so we say the Y values go up forever. If you can just remember, domain is X and it's left to right, and range is bottom to top and it's Y. Would it help you if I point out that domain alphabetically comes before range and X comes before Y? I don't know. I hope you kind of remember these from previous courses, but I understand if you are foggy after last year. Okay, domain again is X. It's left to right. Is this graph stop going left ever? Does it stop going right? No, so the domain is all real numbers, which we write like this. Okay, you don't need to write the words, you need to write those symbols. That means all real numbers. The range is bottom to top and it's Y values. What is the lowest this graph goes? Yes, and it hits 0. It does not, as long as there's no open circle, you have to assume it hits it. So this hits 0 right there. So we're going to do an inclusive 0. And then the top, does it have a top? It keeps going up, so we say to infinity. We'll do some more domain practice tomorrow. Domain and range, but there's some on the Delta math tonight too. All right, this is a wonky one. You just have to be real careful. Domain is furthest left to furthest right. What is the furthest left this thing goes? X value, -5, and it has a solid circle, so we're going to put a -5. The furthest right, it's a little wonky right here, but I'm going to take that the furthest right is 4, and it is hitting 4, so it's inclusive like this. Now this thing has no arrows, so we're not going to have any infinities. We need the bottom. What is the lowest it goes? Right here, the Y value hits -3. And what is the highest it goes? It doesn't have to be the end point goes, guys. It's got to be the very top. Is that +3? And as long as there's no open circles, you assume it's hitting the value. How do you feel about that one? Okay. All right. Be careful. Anybody want to try this one? What is the furthest left it goes? -3, but it's open, right? So we do -3 with a parenthesis. Then what is the furthest right it goes? Yeah, it goes over to here, so it's a +3, and there's no open circle there, so we're going to assume it hit it. Anybody want to try bottom to top? Yes, it's a little confusing to me because it looks like it hits -2 here, but we're going to go with it showing an open circle for a reason. So -2. Yeah, this one is a little clearer that it's not hitting 3, right? But those are both open circles, so we're going to go with parentheses. Again, bottom to top. All right, I think, oh, we have one more thing. Okay, when you're given a function with an unspecified domain, the implied domain is the set of all real numbers for which it works, okay? In general, I cannot say this enough. You must exclude values of the domain for a function that would result in dividing by 0 or taking the root of a negative number. The domain of a function is restricted by a radical or a denominator. Otherwise, it's all real numbers. If there's no radical and no denominator, it's all real numbers. Unless it's a graph and they've given you something wonky that has open circles and stops and does all kinds of stuff. But when I give you an algebraic expression, the only restrictions you're looking for is it have a radical or a denominator. The denominator cannot equal 0, and the number under an even radical, meaning a square root, must be greater than or equal to 0. Otherwise, it's all real numbers. So if we have this question, Okay, and it said state the domain. You need to only look at the denominator and say the denominator cannot equal 0. Any denominator cannot equal 0. Then you have to solve that. Got to go back to your factoring. You can take out an x. So we're really solving what would make it equal to 0, even though it says is not, okay? So if I set x equal to 0 or x minus 6 equal to 0, I would get 0 and 6. And those are excluded values, okay? So it can't be 0 and it can't be 6. If you were drawing a number line, there would be an open circle at 0 and an open circle at 6. Everything else in the whole wide world works. So to write this in interval notation is miserable. You have to say negative infinity up to 0 with a parenthesis, because everything right up to 0 works. And then you say, starting at 0, I can go to 6, but do you see neither one of those had a square bracket, so they didn't include 0. And then once I get to 6, I can't include 6, but I can include everything above 6. That's a 6, sorry, it's kind of messy. All right. Is there a radical or a denominator in number 7? Is there a radical or a denominator? No. So this is going to be a domain of all real numbers, or negative infinity to infinity. It says determine if it is a function. Anybody have an answer for that? Could we solve that for y equals, and it would say what? Y equals, if we added an x over there, 4x. Can you think about that graph in your head? That's just a line, right? So it is a function. And because it's just a line, you should be able to determine the range in your head as well. Does it go up and down forever? Yeah, so the range is also negative infinity to infinity. This you could graph on your calculator to see what the graph looks like. Okay. I will tell you I think it's going this way, but it looks like this shape. Does that fail the vertical line test? Is that the right shape or do I have it backwards? That's good, okay. Does it fail the vertical line test? No, so is it a function? Yes, it passes the vertical line test. Okay, the calculator is not going to help you get an exact domain here. When you have a radical, what you have to say is what's underneath the radical has to be greater than or equal to 0. This is on the quiz. I don't know that I made one quite this complicated, but there is one with a radical. Whatever is underneath the radical has to be greater than or equal to 0. Okay, this is a messy one, and I didn't make one this messy on the quiz, but if you add 2 over to the other side, you get a 2, right? But what's messy about this one? Yeah, we're dividing by a negative. I did not make that on the quiz. But when you divide by a negative, you have to remember to flip this. Does that sound familiar? Okay. So the x values have to be less than or equal to negative 2/3. Now, because we started with or equal to, the domain is going to say, oh, I'm just kidding. What did I do wrong? It's going to have a square bracket, but which way is this going? If you graphed it, you'd have negative 2/3, and it's less than, right? It's going to the left. So go ahead. with a square bracket. Definitely practice some more of those. Now, what can come out of a square root? Can you ever get a negative out of a square root? No. So the range is going to be from 0 up. You can only get positive numbers or 0 out of a square root. That you could probably tell from the graph. The issue is the graph is not going to give you exact value here. It's going to give you a decimal, probably. You tried to do that by graphing. We will continue to practice with radicals because that's what's on the quiz. All right. Anybody know what this is? It's a parabola, right? With a stretch. If I put a +0 on the end, the vertex is at 1, 0. It opens up. So 1, 0 would be here, and it would be going like this if we graphed it. So what, is there any, okay, it is a domain, it is a function. Sorry, gotta slow down here. It is a function, yes. Is there a radical or a denominator? No, so therefore the domain is all real numbers. The range is not all real numbers, but you can tell the range from the graph. What is the lowest it ever goes? Be careful. It's the y value, right? So it's 0 because it hits the x-axis and up. All right, I'm going to save 10 and 11 for tomorrow and 12. Does anybody need to see another, just a domain of a graph? All right, so the assignment tonight is 1.1 functions in Delta Math, okay? It is a Delta Math assignment. If we were to factor the denominator here, the two values that x could not be would be 3 or 5. So the domain would be everything except 3 and 5. If you look at the graph, it is a function. The range is very hard to determine. That's why I said here, just do the domain for these. Normally, what's underneath a radical has to be greater than or equal to 0. But if it's the denominator, it can't equal 0. So we're going to say that doesn't work here. And we're going to say it has to be greater than 0 because it's in the denominator. So this becomes x is greater than 5. So we'd have 5 to infinity for the domain. This one, the domain was all real numbers except these. I can talk more about these tomorrow, but the quiz is not that complicated. This one, if you factor the denominator, what two numbers would make that 0? 0 for this guy or 3. So x cannot be 0 or 3. And if you had to write that in interval notation, it would be really messy. All right, guys. Thanks for being patient with my disaster at the beginning of class.